All right, so let's try drawing Lewis structures for an element today. Individual elements, neutral elements, okay? So remember that a Lewis structure is a two-dimensional representation of the element's valence shell of electrons. Remember that a valence shell of electrons is the last outer shell where the electrons are located, okay? So let's imagine we're asked to draw the valence shell of electrons for, okay, one of our favorite elements, hydrogen, okay? So let's have our hydrogen. How do we know, okay, how many dots to place around? Okay, you go to your periodic table and you find hydrogen, okay? All right, hydrogen right here, okay? Now, which piece of information tells you how many valence electrons it has is the group where it's located. Okay, so if it's in group 1, it would be 1 valence electron. If it's in group 2, 2 valence electrons. 3, 4, 5, 6, 7. Noble gases have 8 valence electrons, therefore their valence shell is full and they are not as reactive or unreactive. Okay, so we're asked to do it for hydrogen. So hydrogen is in group 1, so it has only 1 valence electron. So we need to draw how many dots? Well, just 1 dot above it. Okay, so let's try it now for, okay, let's try it for boron. Okay, so we have a beam, okay, and boron we have that it is in group 3, or all right, so it has 3 valence electrons. How are we going to do this? Okay, we're going to draw an imaginary Cartesian plane, okay, and we're going to distribute those electrons evenly around the boron. So 1, okay, 2, and 3. Okay, then you erase the Cartesian plane. Okay, let's try a little bit more. Okay, we have, for example, nitrogen, which has 5 valence electrons. So nitrogen would be an N. Okay, we draw our Cartesian plane. Okay, and you start drawing the valence electrons. 1, 2, 3, 4, 5. Okay, now for the 6th valence electron, its location following our pattern would be right here. Okay, but we need to take into account another theory, VSEPR theory, okay, which tells us that, okay, electrons are located as far away from each other as possible because negative charges repel. So that means the location of this last electron is not here, but as far away from the rest as possible. Okay? All right. Another one last example. Okay? Let's try our chlorine. It's in group 7. Okay, so we're looking to have 7 dots, okay, 7 valence electrons. So chlorine, okay, we have our imaginary Cartesian plane, so we start 1, 2, 3, 4, 5, 6, and 7. Okay, all evenly distributed. Okay, are we placing the last one as far away from the rest as possible? Yes. Okay, thank you.